Today we're going to talk about function composition. When you combine two functions, you form a composite function. A composite function occurs when you compose or evaluate one function for another. Just as with function operations, you must consider all real numbers that may not be in the domain of the composite function. So if f and g are functions, then the composite function of f and g is, and this is red, f of g of x, or sometimes people say f circle g of x, but normally it's f of g of x. Another way that you can write that is just using all parentheses. So if you see f parenthesis g parenthesis x, that means the same thing. Notice that this right here is an open circle. So don't get that confused with multiplication. So this is not multiplication. Often I see students try to multiply the functions, and you don't want to do that. And so when you are evaluating your compositions, you always want to evaluate the inner one first. So in this case, the inner one would be the g of x because it's on the inside. Same thing over here, the inside one would be f of x. So depending on which one you're doing, you would have to look first, and then you're going to use that answer and input it to the second function. So for example, let's say we were given these two functions, f of x equals x plus 1 and g of x equals negative 2x. Now we've evaluated composition of functions before, but with numbers. So now again, we're not using numbers, we're using functions. So if we do it with numbers first, we have, first of all, notice the inside is the f of 3. So that's what it would get evaluated first. And remember, another way to write this would be g parenthesis f parenthesis 3. That's a different way of writing it, which still means the same thing. So the inside function is f of 3, so you evaluate that first. When I evaluate f of 3, that means I'm plugging 3 in everywhere I have an x into my f of x function. Then you are going to take that answer because we're doing g of f of 3. So now we can take out this f of 3 and replace it with the 4. So now we are going to do g of 4. And so g of 4 is equal to negative 2 times 4, which is equal to negative 8. So this entire composition is equal to negative 8. So for this next one, we can do the same thing, except for we're doing f of g of 3. So the inner function, notice now, is g of 3. And again, you could also write this f parenthesis g parenthesis 3. So first you do g of 3. When I do g of 3, I'm plugging in that in for x for my g of x function, so negative 2 times 3, which is negative 6. And then I'm going to take that answer and plug it into f, because again, we're taking this out, because we said g of 3 is equal to negative 6. So f of negative 6 is equal to, and then go to your f of x function, so negative 6 plus 1, which is equal to negative 5. So this entire composition is equal to negative 5. So that's doing composition using numbers. So the next thing we're going to look at is when you have functions such as f of g of x, and you're not plugging in numbers. Now notice that we're plugging in just x. So how do you do this composition? So again, you could rewrite this as f parenthesis g parenthesis x. That means the same thing. And you can rewrite this one as g of f of x. So notice that the inner function for this first one is g of x. So if I rewrite g of x, we get 2x plus 3. So we are taking this function and plugging it in for the entire g of x. So the whole thing is going away. So we have f of, we're taking out the g of x, and we're plugging in 2x plus 3. So unlike before where we plugged in the number, now we're plugging in an entire expression for this x here. So we have x, and I think is it minus 5? So x minus 5. So we're taking out that entire x and we're plugging in 2x minus 3. I didn't leave myself enough room there. and then minus the 5. So again, notice we took out this x and replaced it with the g of x function. And then all you have to do is simplify, so by combining like terms. So we have 2x minus 3 minus 5, negative 3, or sorry, it's plus 3. So plus 3 minus 5 gives us negative 2. So this would be equal to 2x minus 2. Looking at the next one then, notice that the inside function is f of x. So we have f of x, which we know is equal to x minus 5. And again, we're doing g of f of x. And so that means we're taking out this f of x here, and we're going to be plugging in x minus 5. So the g of x equation is 2x plus 3. So we're taking out this x and we're plugging in to that x minus 5. And make sure you use parentheses because you're going to want to distribute. So this becomes 2x minus 10 plus 3. Combine like terms and you get 2x minus 7. All right, so let's go ahead and look at another example. So here we're given f of x, g of x, and h of x. So the first one we have f of g of negative 3, and again you can rewrite this as f parenthesis g parenthesis negative 3. And so for this one, first we want to evaluate the inner function, which is g of negative 3. So g of negative 3 is equal to, everywhere I have x, I'm taking out and putting negative 3. So negative 3 plus 3, which is 0, and the square root of 0 is 0. So we have g of 0, and we take that answer because this whole thing equals g of negative 3. So we're taking that out and replacing it with 0. So f of 0 is equal to 5 times 0 squared minus 4, which this is 0 minus 4, so negative 4. So this entire composition is equal to negative 4. So let's go ahead and do the next one. We have g of f of 2. So g parenthesis f parenthesis 2. The inside function is f of 2, so we're going to evaluate that first. F of 2 gives us 5 times 2 squared minus 4. So 2 squared is 4. 4 times 5 is going to give us 20. And 20 minus 4 is 16. So now we take this answer and we're going to be plugging it in here. So we're doing g of 16. So g of 16 is equal to the square root of 16 plus 3. And that gives us 19, and that's the square root of 19, and the square root of 19 does not reduce. So this is the entire composition answer, the square root of 19. For the next one, we have f of h of 0. So the inside function is h of 0. So we want to evaluate that first. H of 0 is equal to 0 minus 1 over 3 times 0 minus 7. So 0 minus 1 is negative 1. 3 times 0 is 0 minus 7, so negative 7. So that gives us 1/7. When you take this answer, you're going to take out the h of 0 and replace it with 1/7. So now we're going to do f of 1/7. So that's 5 times 1 over 7 squared minus 4. And again, we don't want to use our calculator, so we need to do this without the calculator. So remember, when you're squaring something in parentheses, that means the 1 squared and the 7 is squared. So 1 squared is 1, 7 squared is 49. So we have 5 times 1 over 49 minus 4. And remember, this 5 is really over 1. So how do you multiply fractions? You multiply numerator times numerator, denominator times denominator. So this gives us 5 over 49 minus 4. And remember that 4 is really over 1, and the reason I want that is because when you add or subtract fractions, you need a common denominator, which we don't have right now, but not hard to get. We know to make this a common denominator, what's common between 49 and 1? 49, so we need to multiply this by 49 over 49. So when I do that, I would get 5 over 49. And again, remember you're multiplying numerator times numerator, denominator times denominator. So this is 196 over 49. And to subtract the fractions, you combine the numerator over your common denominator. So 5 minus 196 gives us negative 191 over 49. And that's the answer to this entire composition, negative 191 over 49. And for this next one, for D, we have g of f of g of negative 2. So now we have multiple things. So we want to do g parenthesis f parenthesis g of negative 2. So again, you always evaluate the inside function first, and then you do the outer function. What's the inside function? G of negative 2. So I evaluate that first. G of negative 2 is equal to, so go back up here, the g function is root x plus 3. So root negative 2 plus 3. Negative 2 plus 3 is 1. The square root of 1 is 1. So now I take this answer and I'm plugging it into right here. So I'm taking that out. So that would give me g of f of 1. So g of f of 1 now. And again, the inner function is f of 1. So f of 1 is equal to, and then go back up here, 5x squared minus 4. So 5 times 1 squared minus 4. 1 squared is 1 times 5 is 5 minus 4 is equal to 1. And now I'm taking this answer and replacing it here with the f of 1. So now I'm doing g of 1. And g of 1, of course, we're using that g of x function again, which is root x plus 3. So this would be root 1 plus 3, which is the square root of 4, which is equal to 2. So this entire composition is equal to 2. So you evaluate the inside function, and then you keep replacing it into the next function that you have. So even if we were to have another function here, we would just keep entering it into itself. So you have discovered that the graphs of a function and its inverse are reflections over the line y equals x. You can also algebraically determine if two functions are inverse of each other using function composition. The table below summarizes the relationship between inverse functions. If f and f inverse are inverse functions, then f inverse of f of x equals x, and f of f inverse of x equals x for x in all the domains of both the function f and f inverse respectively. So for this, that just means that why would we get x out if we put one function back into the other if it's an inverse? Well, if y equals x is the line of reflection, then you're just basically remember undoing what you did before. So it makes sense that you would get x out for your solution. When you're doing this, you must check both compositions in order to verify that two functions are inverses, because one composition may work and the other one may not. So that is very important to make note that you check both and do both of the answers. And again, you need to write it out how we're going to write out here in just a minute. So let's go ahead and do the practice. So 3 says determine, it should say determine if each pair of functions are inverses. Sorry, that should say if. Okay. So for the first one, we have these two functions. We want to determine if they are functions. So we have two things to look at. F of g of x has to be equal to x. And the second thing we want to look at is g of f of x has to be equal to x. So I have to show both of these in order to verify if they are inverses of each other. So let's go ahead and take a look at the first one. So for the first one, the inner function of g of x, which we know is 1/5 x plus 4/5. So I'm taking this answer right here and I'm taking out that g of x. So I'm going to do f of that answer. And so I'm going to write this a different way for those of you who might still be having trouble. So we're doing f of g of x. And so remember, the f function is 5x plus 4. So we're going to be taking out this g of x, and we're going to replace it with the 1/5 x plus 4/5 and plugging it in for this x here. So I'm going to erase this right here, and I'm taking that whoopsies, and I'm doing 1/5 x plus 4/5. So now I plug that in everywhere I have an x, so right here. I'll run out of room here. So 1/5 x plus 4/5. And then there was that plus 5 that I had to erase to have more room. And now I want to solve this. So 5 times 1/5. Remember, this is really 5 over 1. That just is 1x. 5 times 4/5 would be 20 over 5, which is just plus 4. Something's not right. Oh, it's 5x plus 4, not 5x plus 5. Sorry. So 5x plus 4, that 4 should have been 4 there. So 5 times 4/5 gives me 4. And then we have plus 4. So notice these 4's do not cancel out, so that gives me x plus 8. So right away, this is not equal to x. Therefore, I know these two functions cannot be inverses. So since f of g of x does not equal x, they are not inverses because they did not undo themselves. And we could do the next one just to also confirm. It's not necessary if you show that the one does not equal, you can stop there, but let's go ahead and do the other one just for practice. So we have f of x is the inside function. F of x is equal to 5x plus 4. We're going to take that and plug it in here. So we have g of x. So g of x is 1/5 x plus 4/5. What are we plugging in? We're plugging in the 5x plus 4. So 5x plus 4 goes into every x. And then we're going to distribute and combine terms. 1/5 times 5 is just 1x. 1/5 times the 4 gives me plus 4/5, plus this 4/5 here. How do you add fractions with a common denominator? You combine the numerator over your common denominator. So this would be x plus, and 4 plus 4 is 8/5. And again, this is not equal to x, and so same thing, because that doesn't equal x, we know they are not inverses. So let's go ahead and practice the next one. So we need to show f of g of x equals x, and we also have to show g of x, or excuse me, g of f of x equals x. So let's go ahead and look at the first one. F of, or actually, I should write the inside function first. So g of x is x squared minus 4. And then we're going to plug that in here. So this is f parenthesis, and then this is root, take out the x, so parenthesis plus 4. What goes in that parenthesis? We know the g of x function, so x squared minus 4. And when I simplify, square root of, this is x squared, negative 4 plus 4 is 0. So the square root of x squared is just x. So this one checks out, but again, you have to show the other side because sometimes it might work for one and not the other. So always check both sides. So for this one, we have f of x, which is root x plus 4. and we're plugging that into the g of x function. So g parentheses is parentheses squared minus 4. And again, what are we plugging in? We are plugging in the square root of x plus 4. And when we do that, when you have something squared and you're taking the square roots, that cancels itself out. So that means that is equal to x plus 4 minus 4. Those cancel out to give you 0, so that is equal to x, so that checks out. So then we would have to write our concluding statement. So since f of g of x equals g of f of x, and they both equal x, they are inverses. So you need to show the work and write the concluding statement. All right, so let's go ahead and talk about some application problems. A video game store adds a 25% markup on each of the games that it sells, and in addition to the manufacturer's cost, the store also pays $1.50 in shipping charge on each game. Write a function to represent the price f of x per video game after the store's markup. So we're going to say let's x equal the initial price. And so if x is the initial price, so then we would get f of x is equal to the initial price plus the 25% markup. So 25 times 0.25, because we don't want to use a 25%. You have to write it as a decimal by multiplying or dividing that by 100. So that gives you 0.25x. And if you add these together, remember these are like terms because they both have x to the first power. So 1 plus 0.25 is 1.25. So f of x is equal to 1.25x. The next one says write a function g of x to represent the manufacturer's cost plus the shipping charge. So the shipping charge was $1.50. So g of x is equal to x plus $1.50. And C says, suppose the manufacturer's cost for a video game is $13. Use a composite function to find the costs at the store if the markup is applied after the shipping charge is added. So for this, that composition would have to be f of g of 13. Because again, it says use a composite function to find the cost at the store if the markup is applied after the shipping charge is added. So this would be g of x first because again, that is when we did the shipping charge. So the shipping charge has to be first. So to evaluate this, this would be g of 13. So g of 13 would be 13 plus $1.50, which is going to give us $14.50. And then we take that answer and plug it into f. So f of 14.50, which is equal to 1.25, because that was from A, times 14.50, which gives us $18.13. So that would be our solution. D says, suppose the manufacturer's cost for a video game is $13. Use a composite function to find the cost at the store if the markup is applied before the shipping charge is added. So that would be now g of f of 13. So for this, we would be doing f of 13 first, which would give us $1.25 times 13, which is $16.25. And then that $16.25 is being plugged into g of x function. So that is 16.25 plus $1.50, and that gives us $17.75. And so notice that for this problem, um, it does matter which order that you are doing the composite function. And so if you do the shipping charge first versus the second, the one you're going to get charged more than the other. And that is all for our composition of functions.